Hey everybody, it's Mr. Carr again. Today we'll be looking at 4.3, graphing simple rational functions. So what is a rational function when it looks in terms of the graph? So a function as a variable in the denominator is called a rational function. The sketch of the graph we are exploring today is what's called a hyperbola. Okay, so when we do our hyperbolas, we do our graphs, we're going to sketch these what's called the branches of the graph, but the asymptotes must be accurate. These are lines that the graphs are going to approach, but never actually intersect, but never intersects. Okay, so we're going to look at the graph of y equals 1 over x. I'm going to go to Desmos first just to give you a feel for how this looks. So here is my 1 over x function. This is actually the parent function of a rational. So when I look at this, you notice how the graph goes up and up and up and approaches this y-axis, but never crosses. Same thing here. It's going this way and it's approaching the x-axis going this way, but never crosses. This blue section here and blue section here are my branches. Notice how they approach the axes here. That's what's creating our asymptotes is the idea. So when I come back here to graph this, we have a vertical asymptote at what's called x equals 0. Okay, that's this idea here. It's going to approach the x-axis. That's our vertical line. Sorry, approach the y-axis. Our horizontal asymptote, we had a similar idea, is this, and that's y equals 0. So when we look at our values, the reason for this is we cannot divide by 0. So because of that, since we can't divide by 0, that's what's creating this. We are not allowed to put in 0 for x, which means that's related to my domain. Domain is going to be all real numbers except x cannot equal 0. Okay? Same thing with the range. Because we cannot divide by 0, this whole thing here cannot equal 0 either. So that's why my ranges also cannot be 0. So again, those are related to those horizontal and vertical asymptotes like that. And so my rough sketch here, I know it's going to be look like this. If I go to 1/2, that goes to 2, goes to 2, goes to 1/2. It looks like this right here. Okay, there's my sketch. So again, your sketches should not be crossing these asymptotes right now. With this type of style of rational function, it approaches this. It gets closer and closer and closer here, gets closer and closer there, but it will not cross those axes. All right. So let's take a quick look at 6 over x compared to 1 over x. We'll go to Desmos real quick to track that. Look what happened to that. So you look at the green function compared to the blue function. Like those branches still in the same spot. So when I come back here, did the domain and range change? No, there's no change. Do the vertical horizontal asymptotes change? No, no change there. What happens to the graph as the numerator increases? They kind of stretch out. Okay. So, when I say they, I should be more specific. The branches stretch out more. Okay. So what we get is we get that, like, here's my hyperbola like this. Okay. But with this one, we get stretched out more like that. Okay. So it's pulling it away from that origin, basically. So it's just kind of creating, like I said, it's creating a stretch is what it's doing. So what do you think would happen if the graph of the numerator was negative? Well, let's take a look. Let's go back to the original. If I make this, actually, we'll come back. We'll just make that change there. Let's make it a -1. Look how it flips. We get this reflection is what we get. Okay. And if I do like a -6, we get the reflection and that stretching there. So we get a stretch, or sorry, a reflection here. That's the idea. Okay. That all comes together to look at this version of our simple rational functions. We can write them in this format of a over x minus h plus k. H is a horizontal shift. Okay. So our horizontal shift, excuse me, our horizontal shift is going to be based on this number here. And it is because so what we need to be careful of is, since we can't divide by zero, the question I like to ask is, what x would make that into a zero? That is what's creating our vertical asymptote. The k value here is going to cause a vertical shift. Okay, so again, this is going to affect the range, and it's going to help tell us a horizontal asymptote. So it moves the whole thing up and down. Okay, if A is positive, the branches are in quadrants 1 and 3. But if A is negative, our branches are in quadrants 2 and 4. The bigger A is, the farther the branches will be from the axes. They kind of stretch out more that way. So I just want to show you real quick all that shifting before we get to the actual graphing here. So if I do this, let's do this as we got x minus h. Do the h in there. And then plus k. And we'll add our sliders in. So again, this is our normal version. Oops. Add 0, 0. So no shifting at all. No hello. Okay. So no shifting. But then if I make h a positive number, so like something like this is x minus 2. The whole thing shifts to the right. So x minus 2 means it 2 to the right. And then if I go the other direction, which turns into like a plus 8 here, that moves it to the left. Then I can also go up and down. So this is going up 4-ish, like right there. Goes up 4. It's a plus 4 at the end, or I can go down. When I look at my equation, like I could do this, x equals h, and then x equals k. Okay. Or sorry, I got to do negative k here. Oh, what am I doing? That's supposed to be y. Y is equal to k. My bad. So you can see those are my, I like to do it as a dash line just to show them a little bit differently. You can see the vertical and horizontal asymptotes. So as I move this around, this is changing my vertical asymptote. This one's changing my horizontal asymptote. Okay. So my asymptotes change along with H and K changing. So that's what we're showing with that part there. So before I get to that, I'll go back to the graph, but before I do that, let's talk about how to do this by hand then. Graph this. We want to start by drawing our asymptotes, then state our domain and range. So first off, our vertical asymptote is going to be based on this right here. Since the one value that would make this a 0 is the thing I cannot put in, right? We cannot divide by 0 here, which means if x equals a -2, that would make that problem for us. So I'm going to graph x equals -2. So that's going to go like this. My horizontal asymptote is based on this number here. So that's going to be y equals a -1. And there's y equals -1 there. So x equals -2, y equals -1. So x equals is my vertical line, y equals is my horizontal line. From there, we just want to get a feel for what's going on here. Since that's a -4, I know it's going to stretch here and here. If I want to be a little bit more accurate, notice how I'm crossing the x-axis here. That means I could plug in 0 for x if I wanted to. So if I plug in 0 here, I've got, just for the fun of it, I'll put it over here. So I've got right there. So y is equal to -4 over 0 plus 2 minus 1. This is a positive 2. So -4 divided by 2 is a -2 minus 1, which equals a -3. Crossing right there. That's enough to know that I'm just going to have like my sketch kind of look like this. And then again, the other version is going to look like that. Okay. If I want to be more accurate, I can go to like Desmos to get a feel for that. And that's what I'll do right now. There. Okay. You see how that looks there. One thing that might be helpful, it crosses at -6. So if I want to go back and be more specific, I could do that. I'm crossing there at 0, -3. If I were to do my actual value, so we have, let's see here. Turn these on. So I got my h equals a -2 here. There's my vertical asymptote that we just had. And K is equal to a -1, sorry. Right there. Nope, close enough. Okay, so there's my vertical and horizontal asymptotes that match up to that. All right, so again, I could have been more accurate with this part of the graph. You don't necessarily have to be, but sometimes I like to be. So 1, 2, 3, 4, 5, 6. It crosses here. Okay. All I'm really looking for is that you have the rough idea of the sketch. Are your branches in the right areas versus and also are your vertical and horizontal asymptotes graphed correctly? Okay. So last one here. Oh, sorry, I forgot domain and range. So remember, with our domain and range, our asymptotes right in these cases are basically the numbers that can't be. So in this case, x cannot equal to a -2, y cannot equal to a -1. Okay, we can do what's called interval notation. If I'm saying this, and we'll hold off on interval notation. Never mind. All right, this one will do the same kind of steps. So based on my -4 here, x equals a +4. That's what would create a 0 there. So I'm going to graph that here at 1, 2, 3, 4. Okay, my horizontal asymptote going to be based on this +1. So y is equal to 1 here. So I'm going to go right there. This is a +5. So that I know, based on the shifting of everything, it's going to be in these two areas. So if I want to be more accurate, I could find my y-intercept. So I plug in 0, for example. That's going to be 0. Yeah, I'll just do it down here. So y is equal to 5 over 0 minus 4 plus 1. That's going to be 5 over a -4, so or a -5/4 plus 1, which comes out to a -1/4. So it's going to cross like right about there. Okay. And if I want to be more specific on the other points, I could be. So let me just go ahead and go to my graph. Turn those off. So I'm crossing at -1, and there's my 0, -1/4. Okay. So so crossing at -1 right here. And we're going to go ahead and do that. And that's it. And then target domain range, basically x cannot equal to 4, y cannot equal to 1. So officially what's really happening is it's all real numbers except those specific values, right? So x can be any number I want in the x direction as long as it's not 4. Y can be any number I want in the y direction as long as it's not 1. All right. And that's it for today. So we're really focusing on this version. Oh, come back here. This version of our rational functions. How does it shift? How does it, what creates our vertical asymptotes or horizontal asymptotes? All these things are important to be able to graph this and analyze what happens to that graph in terms of domain and range. All right. That's it for today. Take care, everyone.